Hello and welcome back, or welcome to the first lesson to be taught for Distance Learning 2020. We are going to start prepping for our 4-4 lesson, which the book assumes that we understand a couple concepts, but because it's probably been a while since we've either learned them or we never did learn those concepts, we're going to spend time today or in this video and the next video, to cover those two concepts I'm calling pre-4-4. So one of the pre-4-4 concepts is simplifying square roots. Okay, so to do that, we have to understand a couple topics. One of those is the product property of square roots. If we have a square root of two factors, a product, A and B, we can break those two up into two square roots multiplied together. So the square root of A times the square root of B. When we do that, when we're simplifying, we want to try to have one of those factors as the largest perfect square possible factor of A times B, whatever that is. Okay, and I'm going to go through that. But that's one thing you need to know: the square root of A times B is the square root of A times the square root of B. Another concept is that if you have two factors that are the same, the square root of x times the square root of x, that of course is just x. So that's going to come up as well. Okay, so let's go through example square root of 8. If I wanted to simplify the square root of 8, so I would say, okay, simplify is the directions, and the square root of 8. What I'm going to do, and I suggest you use your factor sheet that I've given you. If you do not have this, I put a copy under materials on Google Classroom. You can always print it. But if you go to 8 on your factor sheet, you are looking for one of these numbers that are perfect squares that go into 8. The biggest number possible. Okay, 8 is pretty simple. We already know that that factor is 4. 4 is a perfect square. Of course, that's 4 times 2, so I break it up into those two factors. Now, to simplify, we actually now take the square root of the perfect square, which of course is 2. The square root of 2 is not simplifiable because it's not an integer. And so the square root of 2 stays the square root of 2. That is simplified form for the square root of 8. The square root of 8 is 2 square root of 2. Square root of 18, same thing. Take the square root of 9 times the square root of 2. That is 18. The square root of 9 is 3. 3 square root of 2. There's my answer. The square root of 15. Look at that on my sheet. I realize the only factors for 15 are 1 and 15, or 5 and 3. No perfect squares, so the simplified answer for the square root of 15 is the square root of 15. That's as simple as it gets. Now, you might say, well, there's 1. 1 is a perfect square. Well, yeah, we could do it that way. We could say, well, there is a factor of every number that is a perfect square, and that's 1. Well, that's the square root of 1 times the square root of 15, which is just 1 times the square root of 15, which of course is just the square root of 15. So that's still the answer. So we typically don't use 1 as one of our factors because 1 doesn't really change anything. Okay, so examples. Let's look at this example here, square root of 50. Now the square root of 50, if we look at our sheet, we realize the square root of 50 is the square root of 25 times the square root of 2. Now the square root of 25, because it is a perfect square, its square root is an integer, so therefore that's simplifiable. We get 5 square root of 2. Square root of 81. Okay, that's a perfect square. That in itself is a perfect square. So we just go ahead and say it's 9. Square root of 176. Okay, you might have to look at your factor sheet, or you might have to start dividing it by perfect squares to see what goes into it. The square root of 176, the largest perfect square that goes into it is 16. Again, I like to put the square root of 16 first, the square root of 11 second. So when I take the perfect square root of the perfect square, I get 4 square root of 11. This time I have a negative square root. When you have a negative in front of the square root, you do the same thing, just your answer is going to have a negative in it. So it's negative the square root of 4 and the square root of 30, which is negative 2 square root of 30. Now you might think, oh, 30 looks like it has a perfect square factor. Well, if you think about 30 is 6 times 5, which is 2 times 3 times 5. None of those are the same. If those factors were the same, then you'd know it has a perfect square factor still in it. Since 30 does not have factors that are doubling up, 2 2s, 2 3s, or anything like that, then we know there is no other perfect square factors. All right, now's the time we're going to do a try these problems. I have listed 4 of these that I would like you to try on your own. So this is the time where you would stop the video, make sure you have your notebook out, make sure you have your book out, make sure you have your calculator, make sure you have your factor sheet. Pause the video, try these problems. And then I will cover them here and see how you do. Okay, so pause the video, try them. I'll see you in a little bit. Okay, so hopefully you tried those problems, and now we're going to go over them and see how you did. 75, when I look at the factor sheet, 75 has a perfect square factor of 25. So 25 goes into there 3 times, which is 5 square root of 3. So the simplified answer for the square root of 75 is 5 square root of 3. Square root of 60. Well, I can think of one of those, 4 and 15, which is 2 square root of 15. Negative square root of 45 is negative the square root of 9 and the square root of 5, which is negative 3 square root of 5. And 156, look at the sheet, 156 has a perfect square factor of 4, so that's the square root of 4 and the square root of 39, which is 2 square root of 39. So hopefully you got those right. Hopefully you understand how to simplify square roots, because we're going to be doing that in section 4.4. I will now cover solving quadratic equations using square roots.